Now, another term is the mean absolute deviation. The mean absolute deviation is another way to describe the data set, and it is basically the average distance between each data point. So we basically take the absolute value of the difference between each individual observation and x bar, which is the sample mean. We add them all together and we divide by n. So while there are some applications for the MAD, it's limited in its overall usefulness, but it can be used to compare the spread of two data sets. In Excel, we could use the function AVE_dev to calculate the mean absolute deviation. In general, it's a good point to know that the standard deviation is about 25% higher than the mean absolute deviation. But in general, it's good to know this, but you'll be using standard deviation more than anything else. Now, another main concept is the skewness and kurtosis. Skewness and kurtosis basically help us understand a little bit about the normal distribution, a normal distributed curve. Now, it's a way to measure symmetry of the data. So let's assume that we have a standard bell curve. The symmetry of the curve can be seen. That's the one in the middle. Now, if we have a skewness, which we can measure in Excel using the skew function, again, skew with the data put in. If the function returns a negative number, we have a negative skew. And if the function returns a positive number, we have a positive skew. Numbers close to 0 are indicative of symmetry. So a negative skew is the one on the left, and it refers to a long left tail. So when we say negative skew, you're looking at where the tail is. The tail will be to the left. And if we're doing a positive skew, the tail will be to the right. That's where the long tail is. Now, kurtosis is another concept, and many statistical books state that kurtosis is a way to measure the flatness of the curve, describing how the tails compare to a normal distribution. Now, the kurtosis can be calculated in Excel using the kurt function, and this is kind of a way to take a look at it in terms of the graph. Leptokurtic is really basically very narrow, thin tails, and the platykurtic is a larger, kind of like fatter tails. If you have a kurtosis less than 3, then it's going to be platykurtic. If you have a kurtosis greater than 3, it's leptokurtic. And if it's around 3 with very small deviances, then it's going to be mesokurtic. Now, it should be noted, there was a paper by Dr. Westphal, which in 2014, that basically described the kurtosis as its really only interpretation is in the terms of tail extremity, either existing outliers or the propensity to produce outliers. So this is a very, very deep statistical concept, but I know the author is trying to change some of the perceptions that have been written in statistical books about the kurtosis itself. So it's really a measure to understand, and I would say the easiest way is the propensity to produce outliers.